Welcome to our series on trigonometry. We are going to start out with angles and their measures. We'll talk about what a ray is, what the different angles are, degrees and radians, and go from there. First off, let's define what a ray is. A ray is part of a line that consists of an endpoint and all points on the line to one side of the endpoint. And when you're naming a ray, it's important that the order in which you name that ray matters. Let's say I was going to have the ray PQ. The way that I would name this is I would name it PQ because the point P is my endpoint and then it goes on through Q. So I start with P and then I go through Q. Now we create an angle by rotating this ray around that endpoint P. We have our initial side, which is where we're starting with that PQ point, and then the terminal side is wherever that ray ends up. And then the vertex of the angle is, let's say in this case, it would be P because I'd be rotating around that endpoint. So the angle is rotating a ray around its endpoint, and you're creating this angle on the inside. In this class, we will represent angles a lot using the Greek letter theta. Now, the initial side, like I said, is the angle starting point. So it's the initial side of the ray where you're starting, and the terminal side is the final position. Essentially, I start out with this ray. I had PQ, and then I take it and I'm going to swing it open to create some angle. So we have our initial side, which is the one that is horizontal, and then the terminal side, which is the one that is sort of at an angle here. Now remember the vertex. We're going to name that vertex P for this example because it's the letter that corresponds to that endpoint. You can see here to the right in this drawing, we've got our vertex labeled, our initial side labeled, our terminal side labeled. We have theta for our angle. This would be, the vertex would be A. We had rays AB and ray AC, where we would start at AB and we would rotate that open and get AC. We have what's called standard position on a angle when it is on an XY plane and the initial side starts on the positive X axis. So you can see that in the diagram to the right. So you're starting in between quadrants 1 and 4, and then I swing open whatever angle desire that I have. And notice here I'm using alpha for the angle. You can use a variety of different letters. We're using Greek notation. Again, like I said, theta is most common, but it's not the only thing that we'll be using. Now, the measure of an angle quantifies the direction and the amount of rotation that you have when you're talking about an angle. So if you have a positive angle, that means it's going counterclockwise around the quadrants. And if you have a negative angle, that means it's going to be rotating clockwise. For instance, if I have a drawing here and I have a positive angle, my initial side is going to start here, and then it's going to swing to the left or counterclockwise. If you're talking about something that is negative, you're going to swing under or clockwise. Think about it following the quadrants. Your quadrants are labeled starting in the upper right-hand corner as 1, 2, 3, and then 4. And so if you have a positive angle, you start in quadrant 1 and you go through in numerical order. If you have a negative angle, you're actually going in reverse. You've probably heard this before, but complementary and supplementary angles. Complementary angles add up to 90 degrees. Complementary angles form a right angle based on the fact that it is 90 degrees we're talking about. So for instance, if I had an angle here and then I had another angle here, then I could say that alpha and theta are complementary angles. Sometimes I hear people say complementing is the right thing to do. That helps you remember that complementary is 90 degrees. Supplementary is 180 degrees. So two angles that sum to 180 degrees. That's a straight line. In my straight line, if I have one angle that opens here, and then I have the other angle, let's call this one beta, and we'll call this one delta. In this case, beta and delta are supplementary. Now, I mentioned degrees, but what is a degree? A degree is a way in which we describe an angle. It's a way that we measure an angle. It's not the only way we measure an angle, but it is one way to measure it. And whenever you are doing an entire rotation around a ray from the endpoint, so if you're starting in quadrant 1 and you go all the way around back to where you started, that's a full 360 degrees. And so 1 degree is 1/360th. You'll hear people say, they did a complete 360 to change, which is not true. 360 gets you back to where you started. So you would say they did a complete 180. So 180 means you are halfway around. So you've turned from where you started back to where you began. Degrees, minutes, and seconds are different measurements for, it's a way to break up a degree. So if you need to go smaller than a degree, you can go into minutes and seconds. And so we have a degree symbol, minutes symbol, and second symbol. So degree is with a little circle, minutes we use an apostrophe, and seconds we use 2 apostrophe. And 1 minute is 1/60th of a degree. 1 second is 1/60th of a minute. You'll see notation to tell you degrees, minutes, seconds. For example, you would see something like 74 degrees, 15 minutes, 21 seconds. We could write that as 74 degrees, 15 minutes, 21 seconds. That's the notation. And then I've got this notation here that says see skill practice 1 and 2. You'll see that throughout all of the guided notes in this series that we cover. That's going to be an example where you can see this application of converting degrees, minutes, and seconds. A radian measure is another way in which you measure an angle. When two lines or rays cross a circle, the part of the circle between those points is called the intercepted arc. And this is often denoted by S. Then we have this central angle at the vertex of this circle. So I'm going to enlarge this picture. You look at this picture here, and I've got these rays. Here's one ray, here's another, and it's intersecting the circle right here. So this is called the intercepted arc. We call that S. And then this angle theta is a central angle because it's in the center of the circle. The endpoint or the vertex is at the center of the circle. So we call this a central angle. Now, a center angle that intercepts an arc on a circle with a length equal to the radius has a measure of 1 radian. Let's say that again. When the radius is the same length as that intercepted arc, so the arc and the radius are the same, that is 1 radian measure.